Good evening everyone. I welcome you all to the problem solving session of the NPTEL course on IC engines and gas turbines. I am Pradeev E. I am one of the TA for this course. So today I have some previous assignment problems and then finally I also have some problems on IC engines which will be interesting. Okay, so first question. For incompressible flow through diffuser, pressure always increases but velocity remains constant, or pressure decreases when the inlet flow is supersonic. Velocity always decreases and pressure increases. Velocity increases when the inlet flow is subsonic. So option is C. For the incompressible flow through diffuser, velocity always decreases and pressure increases. So irrespective of incompressible flow or compressible flow, the diffuser means the velocity will decrease, pressure will increase. Only thing that the geometry might be converging or diverging. So for example, in this case, incompressible diffuser, the section will be diverging. The flow will be in this direction. So here dA or I would say area increases as we throughout in the direction of flow. Pressure increases and velocity decreases. So in case of a compressible diffuser, the shape would be something like a converging section, and in this case area along the path of the flow, area decreases, but pressure increases and velocity decreases. The pressure and velocity is same as because it is a diffuser. Diffuser means the instrument that increases the pressure at the expense of velocity energy. Only thing compressible or incompressible flow will decide the converging or divergent section. Next question, which one is correct for the fluid flow through diverging passage? So it is a diverging passage. Always behaves as a diffuser, so that is not true, because based on the flow region, compressible and incompressible changes. Always behaves as a nozzle if the inlet flow is subsonic. If the inlet flow is subsonic, that is Mach less than 1, this section will act as a diffuser. So, but here they have given it acts as a nozzle. So that is false. Next is only act as a diffuser if the inlet flow is supersonic. So if it is inlet is supersonic, that is Mach number is greater than 1, then it actually acts as a nozzle. That is velocity increases at the expense of pressure and energy. So that is third option is false. And fourth one is it acts as both nozzle or diffuser but depends upon the inlet Mach number. So that is correct. So if the inlet Mach number is greater than less than 1, then this diverging section acts as a diffuser. And if the Mach number is greater than 1, then this diverging section acts as a nozzle. Next one, for the supersonic flow through the nozzle, the pressure dash and velocity dash while flowing through it. For a supersonic flow through the nozzle, irrespective of if the supersonic or subsonic, anyway for nozzle the pressure is going to decrease, velocity is going to increase. So pressure decreases and velocity increases. Option C. Function of an intake of the aircraft engine is to increase kinetic rate of the air at the entry of engine, increase pressure rate of the air at the entry of engine, reduce heat loss, increase turbine work output. So the function of intake is to increase the pressure. Next one, select the correct sentence from the followings. the flow velocity along the length of the duct increases for supersonic inlet through diverging duct. So it is through a converging duct. It is a converging duct. The flow across the length, the flow velocity across the length increases for supersonic. So this is false. The flow for a converging duct, only in the subsonic condition it acts as a nozzle or the velocity keeps increasing. So this is false. The fluid pressure along the length of the duct increases for subsonic inlet through the diverging duct. So diverging duct is like this. The fluid pressure along the length of the duct increases for subsonic. So if it is a subsonic Mach less than 1 and it is a diverging duct, across the flow across the length of the duct, the pressure increases. So that is correct. This is correct. Third one, the flow velocity along the length of the duct decreases for subsonic inlet through the converging duct. The flow velocity along the length of the duct. So it is a convergent section. The flow velocity along the length of the duct decreases for subsonic. So for subsonic, it acts as a nozzle. So that means velocity should increase. So this is false. The fluid pressure along the length of the duct decreases for, so it is a divergent duct. Divergent duct. The fluid pressure along the length of the duct for supersonic. So Mach number greater than 1. So in the divergent, actually it will act as a diffuser. That means the pressure will decrease. But they have told the pressure along the duct increases. So that is false. Next, in case of scramjet engine, air enters intake at the dash speed and encounters combustion at dash speed in the combustion chamber. So in case of scramjet engine, the air enters at a supersonic speed and the combustion also will happen with supersonic speed. Only for ramjet it is subsonic and non supersonic. Choose the correct area Mach number relation for varying area duct. So here we can see both option C and D are correct. 8. For a given reservoir temperature and pressure, the flow at the minimum cross-section area of the choked convergent divergent nozzle should be subsonic, sonic, supersonic, hypersonic. For a given temperature, for choked condition, it is sonic. Next one, the flow through the nozzle is said to be under-expanded when the nozzle exit pressure is higher than the ambient or under-expanded means higher than the ambient. Which one statement is correct about ramjet engine? Air enters into the engine at subsonic speed and encounters subsonic combustion. Air enters the engine at subsonic speed and encounters supersonic combustion. Air enters the engine at supersonic speed and encounters. Air enters the engine at supersonic speed and encounters subsonic combustion. So option B is correct. Select the appropriate airflow pattern inside the gas turbine based aircraft engine. So first we will have intake and then compressor and then combustion chamber, turbine nozzle. So D is correct. Which one of the following is correct? Which one of the following is correct for the function of intake used in the subsonic aircraft? It reduces the impact of shock, improves turbine work output, raises the pressure rate of the air at the entry of the engine, raises the any ticket. So answer is it will raise the pressure rate of the engine. In a ramjet engine, air enters from intake with subsonic speed and undergoes combustion with supersonic speed. For fluid through a nozzle, pressure always decreases but velocity increases. Pressure increases. Option is correct. Which of the following statement is valid for scramjet engine? So, free steam supersonic flow enters the inlet. Combustion of the fuel takes place in the supersonic flow. So next, choose the appropriate sentence for the fluid flow through varying area ducts. Converging duct always functions as nozzle. No. Converging duct always functions as diffuser. No. The diverging duct always acts as diffuser. No. Diverging duct acts as both diffuser or nozzle, but depends upon the intake pattern. When the inlet flow through a converging duct is supersonic, the pressure increases while velocity decreases because it acts as a diffuser. Pressure increases and velocity decreases. Next, the flow at the minimum cross-section area of the choked conversion should be sonic for a particular reservoir temperature. The flow through the nozzle is considered to be overexpanded when the nozzle outlet pressure is less than the ambient pressure. And B is correct. Next one, what will be the effect on the efficiency of a motorcycle having a compression ratio of 8 if CU increases by 1.6%? So efficiency of the motorcycle is 1 minus 1 by r power gamma minus 1. Now gamma, so this is, first we can substitute the known value. This is 8 power 0.4. I will get the calculator. So this value is 0.565, that is 56.5% efficiency. Now we need to express gamma in terms of CV so that we can say delta CV is 1.6%. We know gamma is equal to Cp by Cv, and we know Cp minus Cv is equal to R. So this can say Cp is equal to Cv plus R. Substituting this here, we will have Cv plus R by Cv. This is 1 plus R by Cv. So this is gamma minus 1 is equal to R by Cv. So we will have efficiency as 1 minus 1 by R power R by Cv. So now this can be written as 1 minus eta is equal to R power minus R by Cv. We can take ln on both sides, and we have ln of 1 minus eta is equal to minus R by Cv into ln of R. Now we can differentiate this. We will have minus 1 by 1 minus eta d eta is equal to R by Cv square into ln of Now we can write d eta by eta is equal to 1 minus eta divided by eta gamma minus 1, because R by Cv is gamma minus 1, and we will have divided by Cv, so that can be written as dCv by Cv. Now it is given that the Cv is increased by 1.6%, so that means dCv by Cv is equal to 1.6%, or it is 0.016. Eta by eta is 1 minus 0.565 divided by 0.565 into 0.4 ln of 8 into this 1.6%, that is 0.06. That is 1.02%. So this can also be solved in another way. So delta Cv by Cv is 1.6%. So CV dash minus CV is equal to 0.016 into CV. So we can find out CV, the value of CV. So CV dash is equal to 1.016 of CV. That is 1.016 into 717.8. So CV dash is, so this is 729.3. So now we had efficiency is 1 minus R power minus R by CV. So now we have CV dash or beta dash. Now we have 1 minus 8 power. R is 287 divided by CV is 729.3. This is 0.5588. Now delta eta is equal to eta dash minus eta, that is 0.55 into minus 0.565, and delta eta by eta is 0.55 minus 0.565. So we had a negative, this is negative, so the efficiency decreased by 1.0%. So this way we can get the change in efficiency as 1.097% decrement. So here What will be the effect of the efficiency of a diesel cycle having a compression ratio of 20 and the cutoff ratio of 5% of the swept volume if the CV increases by 1%? So we can calculate the del CV dash. CV is equal to 0.717, and they say that delta CV by CV is equal to 0.01. In CV dash minus CV is equal to 0.01 CV. CV dash is 1.01. So that is 1.01 into 0.717. So CV dash. This is 0.724. Now this efficiency in the diesel cycle is equal to 1 minus 1 by r power gamma minus 1 into 1 by gamma into rc power gamma minus 1 divided by rc minus 1. So if you take 1 minus efficiency, then we will have 1 by r power gamma minus 1 by gamma rc power gamma minus 1 divided by rc minus 1. So again we can write gamma minus 1 as is r by cv, and similarly where r comes we can write it as, in place of gamma we can write it as r by cv plus 1. So then this efficiency equation will become 1 minus 30 is equal to 1 by r power or it is also better to take first log and then calculate. So we will have log of 1 minus equal to so applying the gamma minus 1 as r by cv and all, we will get minus r by cv ln of r minus ln of r. Now this can be differentiated. So here we will have gamma minus 1 into TCV by CV divided by this is gamma. And similarly here we will have gamma minus 1 RC gamma. So now we know gamma is 1.4 and V1 by V2 is, that is R is 20 and given, so that means V1 is equal to 20 of V2. So this means Vs is equal to V1 minus V2, so that will be 19 V2 and V3 is given as 0.05 of V5. V1 plus V2, so that is 0.05 into 19. So efficiency is equal to 1 minus 1 by, we have 1 minus 1 by gamma 1 by r power gamma minus 1 into rc power gamma minus 1 minus 1 by gamma into 20 power 0.2 and here 1.15. So this is 0.6. So we can also do the other way where we write efficiency as as a function of CV and then use the new CV value. So that is 1 minus 1 by gamma can be written as R by CV plus 1 into 1 by R power R by CV and then RC R by CV plus 1 minus 1 divided by RC minus 1. Then we have 1 minus so the updated efficiency can be calculated. So we have 0.64573. Earlier this was efficiency and this is new efficiency. So delta eta by eta is equal to eta dash minus eta by eta. So that would be 0.64573 minus 0.649 divided by 0.649. So this is minus 5.038 into 10 power minus 10, that is minus 1005038. So this is 0.5%, 0.504% decrement. The next problem, a petrol engine having a compression ratio of 6 uses a fuel with calorific value of 42 megajoule per kilogram. The airfill ratio is 15. The pressure and temperature at the start of the suction stroke is 1 bar and 57 degrees Celsius respectively. Determine the maximum pressure in the cylinder if the index of compression is 1.3 and the specific heat at constant volume is given by CV is 0.678 plus 0.00013 into T, where T is in Kelvin. Compare this value obtained with that of constant CV of 0.717 kilojoule per kilogram Kelvin. So we need to determine the maximum pressure in the cylinder. So first we can write this P2 P1 V1 power n is equal to P2 V2 power n. Here n is 1.3, P2 is P1 into V1 by V2 power n. So P1 is 1 bar and V1 by V2 is given as compression ratio, that is 6, and compression index is given as 1.3. So we can calculate the second pressure. So this is 10.27 bar. Meanwhile, we can also calculate the temperature. So that is T2 equal to T1 T2 T2 plus T1. So T1 is 57 degrees Celsius. That is 330 into T2 is 10.27 bar and V2 by V1 is 6. So answer is 564 pound, or I would write 564 kg. So assuming unit quantity of air, please. So this is 1 by 15 kilogram of fuel for kilogram of air. So then energy supply can be written as, or that this is Q223 is the calorific value divided by the fuel mass, sorry, into fuel mass. So that is 42 by 15 megajoule per kilogram of air. That is 2.8 megajoules per kilogram of air. So Q223 is CVA M total into T3 minus T2. So here CV mean can be written as 0.678 plus 0.06. So this one is 2800. To write in terms of kilojoules, we have 0.678 plus 0.00013 into T3 plus T2 is 565 F2. So this is CV main. Then M total is 16.13. So solving this equation, we can calculate the value of T3 as 3375 Kelvin. So this is the temperature when we calculate using the variable UCB values. So now we can also calculate the pressure value. So that is P3 is equal to P2 into P3 by T2. So P2 is 10.27 into 3375 divided by 560. So this is 61.35 bar. So similarly, if you have a constant specific heat, then we'll have 2800 is equal to M into CV. So M is 16 by 15 into CV is given as 717 from the 0.717 into T3 minus T2 is 560. So T2 can be this is 4226 Kelvin. So then we will have P3 is equal to P2 into T3 by T2, that is 10.27 into 4226 divided by 560. So this is 76.8. So in the next problem, the air fuel ratio of diesel engine is given as 29:1. The if the compression ratio is 16:1 and the temperature at the end of compression is 900 Kelvin, find at what cylinder volume the combustion is complete. Express this volume as a percentage of stroke. Assume that the combustion begins at the top dead center and takes place at constant pressure. Take specific value of the fuel as the calorific value of the fuel is 42,000 kJ per kilogram, R is 0.287 kJ per kg Kelvin, and CV is 0.709 plus 0.000028 T. So we know Cp is equal to Cv plus R, so that is 0.709 plus 0.000028 T plus R is 0.287. So Cp is equal to 0.709 plus 0.287. So this is 0.996 plus 0.000028 into T. So air fuel ratio is given as 29. So that means fuel mass is equal to 1 by 29 kilogram fuel per kilogram air. So Q23, the energy spent is energy given in the cycle is 42,000 divided by 29 kilojoule per kilogram of air. But we need to consider the total mass here, so total mass will be 30. So that is 1400 kilojoules. So we know Q is equal to integral Cp into dt between 2 and 3. So we have 0.996 plus 0.000028 T dt between the limits 2 and 3. So this is 0.996 T3 minus 900, and this is 0.00. So this is 2246 in this process, V3 is equal to T3 by T2 into T2. So this is 2246 into 900. This is 2.495 V2. We need to express this as a percentage of stroke. So that is, we need to find V3 by Vs, and you know Vs is V1 minus V2, and compression ratio is V1 by V2, that is 16 for this machine. So V1 is equal to 16 V2. Now V3 by Vs is V3 divided by 16 V2 minus V2, that will be 15 V2, and V3 is also can be expressed as 1.495 V2, and denominator will have 15 V2, so V2 can get cancelled. So then we will be left with 0.163. So that means the compression stops at 16.6% of the stroke. So half of the energy is given in constant pressure, constant volume mode, and half in constant pressure. So we can write Q2 to 3 as 1000 kilojoules, because the total is 2000 kilojoules. Now this is integral of Cv into dt. So that is 1000 is equal to integral Cv written to K. Cv is 0.709 plus 0.000028 into t into dt. So now after integrating, we will have 0.709 t3 minus t2. So t2 value is we have 0.0028 t3 square minus t2 square. So here T2 is 1040.6 Kelvin. So we have 1000 is equal to 0.709 T3 minus 1040.6 plus 0.000028 T3 square minus 1040.6 square. So this T3 can be this is 2362 Kelvin. So using this we can calculate the pressure. So P3 can be written as P2 into T3 by T2. That is P2 is 36.26 bar into T3 is 2362 and T2 is 1040.6. So this is the maximum pressure in the cycle. That is 82.3 bar. Next we have Q3 to 4, that is integral Cp dt. So that is between 3 and 4. This is 1000 kilojoules, and here we have 0.996 into T4 minus T3 plus 0.000028 T4 square minus T3 square. So here T3 is 2360. This is 0.996 T4 minus 2360. So if we solve this, we will get the value of T. So T4 is 3290 Kelvin. Now V4 is equal to V3 into T4 by T3. That is T4 is 23292 divided by 2360. So we need to calculate V4 plus Vs, that is this is 1.393 V3, 25 this is V1 and compression ratio is 13, so this should be by 12. V2 and V3 are same. So this is 11.6%. Next, petrol engine with a compression ratio of 7 used a mixture of isooctane and hexane as fuel. The pressure and temperature at the beginning of compression process is 1 bar and 55.2 degrees Celsius. So compression ratio is 7, T1 is 1 bar, T1 is equal to 55.22 degrees Celsius. So that is 328.22 Kelvin. If the fuel air mixture is 19.05%, so FAR is equal to 0.1905, rich, and the maximum pressure developed is maximum pressure for a petrol engine at P3 is 115.26 bar. And then evaluate the composition of the mixture in percentage weight. Okay, CV of different fuels are given. So first we can calculate how much of energy is needed, and then based on that we will be able to calculate. So CV xm is equal to 43, CV isooctane IO is 43, and PV power 1.31 is equal to constant. So first we can calculate the T2. T2 is equal to T1 into compression ratio power gamma minus 1. So that is T1 is 328.22 into compression ratio is 7. Our gamma should be taken, can take it as n minus 1. So and n is given as 1.31. So we'll have 0.31. So T2 can be calculated. So this is 600 Kelvin. You can also calculate P2. P2 is equal to P1 compression ratio power n. So that is 1 bar into compression ratio is 7 power 1.31. This is 12.8 bar. That is P2. Now T3 is equal to T2 into P3 by P2. So that is 600 into 115.26 divided by 12.8. So 3 is so this is 5402.8 Kelvin. Now Q is equal to Q23 is equal to CV into delta T. CV is 0.717 and delta T is 5402.8 minus T2 value, that is 600. So that is 0.717 into 5402.8 minus 600. This is 3443.6 kilojoules. Now, so this is per kilojoule per kilogram of mixture. And fuel air ratio is given as 19.05%. So that means fuel mass is 0.1905 kilogram of fuel for kilogram of air. But what we want is MF by MA plus MF. So we can do MA by MF is equal to 0.1 by 0.110. That is 5.25. Now mx by mf is equal to ma plus mf by mf, or it is also ma by mf plus 1, that is 6.25. and now mf by mx is 1 by 6.25, that is 0.16. So now fuel mass is 0.16 kilogram, and this is giving a calorific value of this is giving a heat energy of 3443.6 kilojoule. Now if we want to add so now this heat energy 3443.6 should be balanced by the calorific value of both fuels, hexane and isooctane. So for hexane it is a m of hexane into 43,000 plus total mass of 0.16 minus m hexane into 42,000. So using this MH can be calculated. So we will have 3443.6 minus 0.16 Okay, so it could be the case that the fuel air mixture is given as 19.05% is rich. So it might be that more than stoichiometric, if the fuel is compared to stoichiometric, it has 19% more fuel. So then we need to calculate the stoichiometric air fuel ratio and then determine this. So anyways, this can be calculated that way. Thank you for participating.